Hello everyone, today I'm going to talk about Docker-compose, Dockerfile, and how you can use them to start your application easily. Let's go. This video is part 2 of my video series on Docker. In the first video, I talk about what is Docker and how you can use it as a developer. If you haven't watched it, please write on the top right corner and go back and watch that video. Now that we are all catch up with the last video, let's talk about what is Docker-compose, Dockerfile, and how we can use them. Let's start with the differences between Dockerfile and Docker-compose. So Dockerfile is a text file without any extension called Dockerfile that you put it in your project. In a Dockerfile, you can put multiple images inside one Dockerfile, and when you run them, you will build one container which consists of all these images together, and then you can start the container and start working in your application. But on the other hand, Docker-compose file is a YAML file. So you might ask, what is a YAML file? YAML file is just a text file with the extension YML, but it's not a normal text file because this text file should follow certain instruction and certain format. If you don't follow them, it's not a valid YAML file and the system won't support it. So in this YAML file, you will define different images that you would like to have, but you will define them in a different containers. This way, if you have a problem with one of the containers, you can just bring that container down and then try to fix it and then load it up again. In this YAML file, we have also instruction for the Docker to how these containers will interact with each other. So for example, what kind of port they are open to each other and how they can find each other. Using Docker-compose is also very helpful when you are having microservices. So you have several different services and each one of them has its own unique environment or a specific requirement that needs to be run. So this way you can put each one of them in one container, and this way you are making sure that they won't have any effect on each other if one of them goes wrong. Now imagine, let's say that we would like to make a web application. So in your web application, you might have a backend that it needs to handle all the code that you're running. You might have a database that you store all the data. You might also need a server so you can run your backend code. You might have some cache system in place. So if you are using a Docker file, you can specify the images that you would like to use for each one of these services in one big Docker file with all the commands and script that needs to be run for each one of the images to run out. But if you are using Docker-compose, you can put each one of them in their own container, and then you can run all the containers at the same time. There is something that I need to mention, that when you're using Docker-compose, it's not something that you said that I will use Docker-compose instead of Dockerfile. They can be used at the same time. So because in the Docker file you can specify bash commands or specific commands or scripts that needs to be run whenever one of the images is running. So it would be really helpful if you can put those commands and those scripts in a Docker file for each container, and then specify it in your Docker-compose file that, okay, if you're running this image that should goes to this container, please run this script that I specified in the Docker file. Now, if you're using Docker-compose, you can put all the specification of the different images that you would like to use and different containers that you might have in one file, and then just by running Docker command Docker-compose up, you will start running all the containers at the same time, and all of them know what they should do. In conclusion, I can say that if you're using Docker-compose, it would be much easier to handle a multi-container application in one place. So you will have a single file, you have all your containers, which contains all the images, how to run them, how they can interact with each other, what libraries they need to run, and what specification do they have. And you can put them, all of them, into one text file. And at the end you can run just one single command, Docker-compose up, and you can start all of them together. This way it would be much easier to handle the configuration between each one of them and the libraries and the version each one use. If you're working in an application that has multiple services, it would be much easier to use Docker-compose and build them on a different container. If you followed my last video and you have downloaded Docker Desktop, then you are good to go, because Docker Desktop includes Docker Engine and Docker-compose. Otherwise, please go to the official website of Docker, find the Docker-compose, and then follow the instruction how to install it. So if you have followed me this far, please like and subscribe and press the bell notification so you will be notified when I uploading similar videos about development. Now let's jump to my laptop and I will show you different examples of Dockerfile and Docker-compose. So welcome back. Now I would like to show you the different examples of Dockerfile and Docker-compose. So first of all, let's jump into Dockerfile. So as you can see here, I created Dockerfile for web application that runs PHP. It has Nginx as a server and MySQL as the database. So in a Dockerfile, you need to specify which images that you would like to run. So how Dockerfile is structured: at first you are mentioning what image you would like to build or pull from the Docker registry. In the Dockerfile, at the beginning of each sentence, you have a one word which is in all capital letters. This is one of the commands for Dockerfile, that it has some meaning. So for example, when you want to mention what image you are working with, you start with from. You type from and then you mention the image name and the version that you would like to run. Then after that, you can specify what kind of commands or scripts you would like to run for that specific image. As you will see here in this example file, I would like to get a PHP image 7.4 and the version FPM, and I would like to install some dependencies and libraries. So I will do a run, which means that it will run some bash commands on the image of PHP. And we have apt-get update, which is update the whole dependencies, and then it install the following libraries and dependency that I would like. So for example, I would like the zip, the extension for the Docker PHP, and so on. Then the next image that I would like to have is an Nginx. Nginx is a server that it will run your PHP file. So here I would say that from Nginx 1.19, one of the version of Nginx, and it will run it. So as Nginx is a server file, it needs some configuration. So I have a file here called nginxconf, which is the normal standard configuration file for Nginx, and I put it in the same directory as my Docker file, and I'm just saying that just copy the Nginx from this directory, which is here, and put it inside of this directory of the image that you're creating from Nginx. Next, for my project, I need a MySQL database. So that's why I'm saying that from MySQL version 8, it means that it will pull an image of MySQL version 8.0. Next, I would like to specify some environmental variables for my database. So here I will describe different variables that I would like to have for this MySQL image that I'm running. So like a username and password, a password for the root user, and also the name of the database that I would like to create. Also, when you are having a MySQL, you can have a schema file which defines the different tables and databases that you want to have. So here again, I'm using the copy command from the Docker file to copy a schema file from my directory to the directory of the image of MySQL. But as you can see on the left side, I don't have this schema file. So I need to create a schema file.sql and put it here. Let me do it. So I will go to my terminal and I will just create a schema.sql. So now, as you can see here, the schema file just been created. But the thing is here, this schema file that I created is just an empty file. It doesn't have any specification or any instruction for that SQL, for that database. That's just for a demonstration that how it works. And then after that one, I need a phpMyAdmin, which is one of the services that it will give you a UI to access your database on the local environment that you have. So here I'm mentioning that I would like to get the phpMyAdmin version 5.0, and then at the end, as you can see, I will say that please copy the source file which contains all the files that I have in my project and put it into this directory inside of these images that it will be created. So the Nginx knows that where the files are located and it can run them. And at the end, I'm saying that the port 80 should be exposed so I can access it via my localhost. And the last script that I'm commanding the Dockerfile to run is the nginx -g daemon off, which is for starting the nginx web server. Now, as you might see on the left side, I have this directory called source src, and if I open it, I have a simple index.php. This file is a simple PHP file. It has some HTML tags and it has a one PHP script which is just exporting the Docker is running. Now, you might ask, okay, how we have this Docker file? It looks a little bit complicated because we are running several different images inside of the same container. So it might possible that we might run into some issues. But first, let me show you how we can work with it. So you will bring back your terminal, and what you need to do is that first of all you need to build this image. Yeah. So what you do is that you say that docker build and dot. So when you put dot, it means that, okay, look into the same directory that you are located now and find the Docker file it has and build an image and a container from the instruction it consists. Docker has another good functionality that you can give a name to your container. So this way you can find it much easily in future. So how you do it is that you do a -t and then you will write, for example, my container, yeah, and then dot. So the dot is the same as before. It just to mention that look in the same directory for the Docker file, and then we press enter. Now, as you can see, it tried to find if the images that I specify in the Docker file are already located on my local machine or it needs to grab them from the Docker registry. And as you saw that the one from the doc.php my admin, it had to run it from the Docker registry. Now everything is done and I have built a container with these images. For me, it didn't take long because most of these images that I put together, I had it on my local previously. So it means that I ran this build for these images before, and Docker has already downloaded and pulled these images from Docker registry. So it had it in its memory, so it just built them and put them together in a new image called container1 for me. Now, the next step is that I need to run this container and to bring it up and to make it live. So the way I'm doing it is that docker run and then container1. Sorry, I did a mistype. So let's do it again. Docker run container1. Now in the last step, I run docker run and you saw that the Docker environment and the container started running. So now I can start using this environment and do my development. Okay, now that was how we define a Docker file and how to work with the Docker file. So this has some advantages and disadvantages. The advantage is that you can define the images and you can define also the scripts in the same file. So you have a very good view of everything that needs to be run when you are creating the images in one container. The issue is that you will create all these images in the same container. So if you have an issue with one of the images or one of the command that one of these images is running, you need to bring down the image and build it completely from the scratch and try to fix it. It makes it a bit difficult to find an issue if you are having all these different images in the same container. So the other solution or the alternative solution would be that you will define each image in the separate container, and that's how we are using Docker-compose. So for showing you how to use the Docker-compose, I will follow one of the interesting articles from the DigitalOcean that which shows how to set up a simple web environment, a web application for a kind of a travel website. So let's dig into it. So the first thing we need to do is that we need to create a new directory. So mkdir, and then I will call it Docker-compose tutorial. Now let's go into this directory. Okay, so I did a git clone and now we have the repository in place. So we can do ls and then we will see that we have a new directory. So we just go inside of it, cd travel, and then we are here on the main branch. Okay, now let's close this directory and open the new one. Okay, so what you see here on the left side with the project tree is that we have a project based on Laravel. So Laravel is one of the PHP frameworks that it's really easy and it has a really advanced feature that helps you create a modern web application. But that's not what we are interested today. What we would like to do today is that I will show you how the Docker-compose file works here. So we will open the Docker-compose YAML file. So first of all, as I told you before, the Docker-compose is a YAML file which has a specific structure and a format. So as you will see here, in the beginning of the Docker-compose, we need to mention which version of Docker-compose we would like to run. So here it says that it's 3.7. Fine. Then we will have all these services. So each service is actually one of the containers that will be created. So as you will see here, we have an app service, which would be one container. We have a DB service, another container, and then we have an Nginx. Each one of them, they are their own container. And so one of the things that we are doing here is that we can give each one of these containers some specific commands via Docker file, which we talked about before. So as you can see here, the app container, which is our app service, it has a Docker file, and the others, they don't have this Docker file, as the specification and the configuration that we put here in this Docker-compose file is enough for making it run. So let's check this Docker file that we would like to run for this app. It's in the same directory, so we'll just open it. We start looking at it. So we are seeing that it will start. It will get an image from the Docker from the Docker registry of PHP 7.4 FPM. Then it will define it will take some arguments from the Docker-compose that we had it up before. So the argument that we are getting is the user and the UID. So it will get these two arguments. It will pass it here, and then it will start using them here as well. At first, it tries to install some dependencies. So it will do a install system dependencies here. So it do a run, and it will go through this one: zip, unzip, get, curl, update, and so on. Then it clear the cache. Then it install the PHP extension again from the run, and then it will copy. And so as I said, that this copy command is when you are copying some files or directories from your local environment and you want to have them in your container where the image exists. So it will does that, and then it will run other commands. As you see that this UID and this user is the two arguments that we try to grab here at the top from the Docker-compose file. So we are using them here. So we said that we are adding this user, and then we are creating this directory here, and then we give that this user the correct rights for reading and writing to the files. So we can do a Docker-compose, and we can do a composer, and at the end we created the Docker directory for our work, and then that's it, we finish it. So the thing is, the composer is a package management tool for the PHP. So in this video I might talk about the composer and Docker-compose, but I will mostly focus on the Docker-compose, and we will cover composer in another video. Okay, now that we saw how the Docker file is specified just for one image and the different specification, we will see that it will make our Docker-compose much clearer and easier to work with. So now here we see that we have these build commands, which has the arguments that we set, the context, which is which directory is located, and which Docker file if it's needed to use on. Then we give it a name, a travel list, and then the container has a name as well. And then we have other criteria. So for example, volume, it says that which directory in our system that it needs to use, and it goes ahead. So we have one container for our database. The DB is our container that contains our database. And here I said that, I mean, it says that in the Docker Compose that it needs to get a MySQL 5.7, and then the container name is a travel list DB, which is the database. It has a real start on the stop, so it's working all the time. And then we have some environment variables, which could be again the database name, database username, password, if it has a password for the root user, and so on. And then we also put that which volume that we would like to use. So this part is that when in the volume part we are actually telling it which directory on our system will be mapped to which directory in the container. So then it will copy the files from our local environment and it will use them in the container as well. Then we are mentioning that it has a network. So as you saw, the network is also available in the top one, which it would be a separate one to show that how these systems will connect together. And at the end, we are having the Nginx, our server, to run our files. So this one, for example, has a specific extra parameter called ports, which it says that which port we would like to expose that our application will run on. And then we have also the Nginx configuration. We are mentioning where it should get it from and where it should be located, and the same network as before. And then at the end we have this network, and then we are using the bridge as our driver to connect all these different containers together. So this was how the Docker Compose is set up here, and the comparison with the Docker file that we talked about before. So as you might saw in our DB container, the database, in front of the environment variables, this is this $sign and the curly bracket with some variable names in them, and it doesn't have the value for each one of them. So you might ask, okay, what is it and how we can get this value? So in reality, when you're working in a big project or in any project, each different environment, they will have their own variables, which means these variables are the username, password, or some specific variable for each specific server or environment that you're running it. So as you can see here, these variables will come from a file called .env, and we don't have it on this side, so we need to create it, but we have something called env.example. So let's open it. Here in env.example, as you can see, we have lots of different variables that we can use in our application. So the values that we were looking for the MySQL are located here. So it's a DB connection MySQL, DB host, DB, the port, the database, username and password. So these are very simple username and password, and you might not want to use them on your production environment. So when you are deploying your application on a production environment and production server, you will create a new env file and you will put the new information for those databases, username and password of databases, or other information that you have here regarding, for example, the mail setup of what is a username, what is a password, what is the encryption, or even, for example, if you have an AWS service connected to it, so the key ID, access ID, you will put it in your env file and then you will save it. So this env file, it won't be shared by anyone or anyone else, and because it's a server specific, it's unique for each environment. So that's why if we wanted to use this kind of setup, we couldn't put it in our Docker-compose file that to put it in an app, because the Docker-compose file, it's a file that we are sharing it with the different environment, with the different people who are working on the same project are using the same Docker-compose file, and it shouldn't be changed. But what they can do is that they can go to open their env file and they change data on their side. So what we do now, right? The first thing that we need to do is that we need to copy the env example to another file called env, and then set our variable there. Okay, now if we are back here, we see that we have a new env file with the data that it was in the env example. And as this is a tutorial that we are working, we don't need to really change the data over here. It's a simple data, and we don't really use it for the environment, so it's okay to keep it simple like that. So the password can be password, the username can be whatever username that we want. But when you are going on the production environment, we need to specify very good password, and it needs to be unique, and also the username and the password, both of them unique, and something that nobody can guess or access them. So then we will put those information in the .env file that we have on those server. Okay, now we are one step closer to running this application and see it in action. So next step is that we have a Docker-compose file ready, we have a Docker file for one specific image ready, we have our env file ready, so we are set to go. So the last thing we need to do is that we need to run Docker-compose up. So Docker-compose up is a command that it will bring up and build the different containers, and you can start using it to do your web development. So let's start. Docker-compose up. There is one interesting thing about Docker-compose up. So if you are running Docker-compose up, it will start building these container, and then these terminal page you have, it will be occupied with showing all the different logs of these containers and what you work on. So if you like to use your terminal for something else, or you want to just bring up your application, start it and forget about it and go ahead, and you don't need to worry about it if you close your terminal, you can run your containers in the background. So how you do is that you just put -d at the end of the Docker-compose up. So this way it will run the Docker-compose in the background. Let's try it. So it starts to pull the different images, and so the Nginx is fine, but we see that we have an error for our application. Let's check it afterwards to see what it is. So as you saw, it takes some time for the Docker to create all these containers and images and run the specific command, especially for the running these different libraries and dependencies that we need for the application. Okay, now that we are set, before we start running the project and I will show you the application, there are two specific commands that they are specific to this project that needs to be run. One of them is the composer for PHP, which we need to run it to download all the dependencies that this application needs. Let's run that one. Now let me show you how to run a specific bash commands for your application. So how we work is that we do Docker-compose. So we are telling we are starting the command with Docker-compose, that we know that it needs to be run the Docker-compose. Then we do a exec. So exec is the execution of any terminal command or bash command that you want to run on your application. Now you need to specify which container you want to run these commands on. So the one with our PHP was app, so we call it app, and then at the end it's like you're in the terminal and then you are running the whatever command that you run. So imagine you haven't worked with the Docker and you have a just normal PHP environment on your machine and you want to use it. So how you do it is that you do a composer install. So now we are doing the same, composer install. This command also, it will take some time. Okay, now it's done. So now we have our local environment with the application is running. We have the composer install, so we installed all the dependency and libraries that our PHP, our web application needs to run. We have our Nginx running, we have our database running as well. Before we start this application, there is just one last command that we need to run, and that one is specific to this framework that we are using for testing the Docker-compose. So this command is Docker-compose, like before, and we do the exec again. So we do the execution of the terminal. We mentioned the app, the same as before, and then the command that we need to run is a PHP. So it's a PHP command that is run. Artisan, which is specific to Laravel and then key generate. Let's try Docker-compose. That's it. Okay, now we have an application key set and register, and we are successful. So now let's go to our localhost and see if the application is up and running. So we write localhost 2 and we are mentioning 8000 as this was the port that we exposed in our Docker compose, and press enter. And now, yes, as you can see, we have our application up and ready. So it's a simple application, and as you see, it works. Okay, thank you for following this instruction and this tutorial and hands-on with the Docker compose, Dockerfile, and how we can start up and running a PHP or a web application using Docker compose. If you have any question, please comment it down below, or if you have any suggestion for the future videos and what subject you would like me to cover, please comment it down below. I hope you like this video. Please like and subscribe and press on the bell notification so you will be notified when I'm uploading similar videos about development and software engineering. Have a good day. Bye.